Welcome. In this screencast, we explain to future elementary educators what we mean by ordering integers. And by ordering integers, I mean if we have two integers, a and b, what do we mean when we say a is less than b? What does that mean? How do we know that a is less than b? So generally speaking, we say that A is less than B if and only if there exists a positive number K such that A plus K equals B. Visually, here's our first side note. Visually, A is less than B if A is to the left of B on the number line. That's what it means to say that A is less than B. So let's see. Let's see if we can put some meat on the proverbial bones. This works just fine when all our integers are positive. We know that 3 is less than 5 because there exists a positive number, excuse me, a positive number, that's a positive number, such that 3 plus 2 is 5. So 3 is definitely less than 5. And on a number line, 3 is less than 5. 3 is to the left of 5 on the number line. So what do we mean when we say that negative 2 is less than 4? Well, we mean that there's a positive number that you can add to negative 2 to get 4. That positive number is 6. And again, on the number line, here's negative 2. It's less than 4. So then what do we mean when we try to compare negative 7 and negative 10? Is it less than? Is it greater than? What's the sign that goes there? Well, we can appeal to the number line. There's negative 10. There's negative 7. Who is further to the left? Negative 10 is further to the left. So we can either say that negative 10 is less than negative 7, or we can say that negative 7 is greater than negative 10. Consistent with our definition, we know that this is true because there is a positive number that we can add to negative 10 and get negative 7. What is that positive number? That positive number is 3. So then what happens when, let's pretend that you have A less than B, and let's suppose that you have some positive number n. How do n times A and n times B relate? Who's bigger? Well, if 3 is less than 5, and n is some positive number like 4, NA is 12, NB is 20, well, 12 is still less than 20. So we would argue that NA is less than NB. This makes sense. When we multiply both sides of an inequality by a positive number, we keep things the way they should be. But what if A is less than B and N is some negative number? How do NA and NB relate? Well, let's suppose that 4 is less than 7 and N is some number like negative 2. Well, NA and NB, well, wait a second. Wait a second. That's the relationship. It would appear that NA is greater than NB. But how can that be? Well, on the A less than B line, B is farther away from 0. It's a bigger number than A is. When we multiply by a negative number, this number is bigger in magnitude, but it has switched sides of 0. So this number is bigger in magnitude, and it's on the left side of 0 now, which means that the sense of the inequality has reversed. So if A is less than B and N is a negative number, then the sense of the inequality reverses. NA is greater than NB. Hopefully this all makes sense to you and you are able to explain it to young people, which is the goal of our course anyway.